uma coisa assim do
Sim,
género.
sim, sim, sim.
Interessante. not a bad number, I think. Maybe some people will join in the meantime, but I'd like to ask the Martin or some other Forum Civil members to accept further people that will join the presentation in the meantime.
Só uma coisa, senhor engenheiro.
Not a bad number, I
Eu
think.
queria
Maybe
pedir
some people will join in the meantime, but I'd
aos participantes
like
para poderem pôr o
ask
vosso primeiro nome e o
Martin or
apelido
some other
para
Forum
podermos
Civil
fazer a
members to
contabilização
accept
para o
further people
giveaway
that
que
will
vamos fazer
join
no
the
final da
presentation.
semana. Por isso, por favor, me dê o vosso nome. Obrigado. Pode começar.
All right. So my name is Pedro Carvalho Costa. I'm a senior structural engineer at WSP in the UK, and I'm here today to talk about HS2 Old Common, UK's largest new railway station. Before I start my presentation, I just like to say thank you to Forum Civil for this kind invitation to come here and participate in another event of Forum Civil. I'm always happy to do so. It's a pleasure for me to share my experience with students, and I also think that it's very important for students to see what the engineering profession looks like in the future and what sort of projects they might have an impact on in their careers. So without further ado, I'll make a start. So yeah, so these are the topics that I'm gonna be covering today. So I'm going to be doing a brief introduction about myself, my academic background, and my career. I'm going to talk a bit about WSP, the company I've been working for the past year and a half, and then we're going to look into HS2 as a whole, the HS2 project within the United Kingdom, and then we're going to focus more particularly in the project that I've been working on, HS2 Old Common. And the two main aspects that we're going to talk about within the project are the structural design, how we've completed the design, which is not complete 99, it's like at 99% complete at the moment. We're still finishing up the design, but it's pretty much there and we're already building it. And the second point is the construction of this great project that it's already on site, and it's something that I've been following with my work on a weekly basis. And then at the end, we're going to have a Q&A session. So if anybody has any questions, I would ask them to maybe write down on a piece of paper and then ask me the question at the end of the presentation. I'm noticing some people on the lobby chat, so if someone could please accept those people, that would be very helpful. Okay, so I'm gonna make a start. So just a bit introduction about myself. So I've studied in Institute Superior Technique, where I've done the integrated master's degree in civil engineering with expertise in structural engineering. That was between 2010 and 2015. And throughout that period, I had two really interesting opportunities just before I finished my degree, which the first one was to do an internship at Algeco, who is a light steel prefabricated contractor that operates in Portugal and worldwide, but they have a couple of offices in Portugal. And I also had the opportunity to do an Erasmus in the University of Milan. Then in 2015, I've moved to the UK and I joined Foster & Partners to work as a structural engineer. And I've worked there for 5.5 years, more or less. And in that period, I've become a member efectivo of the Ordem dos Engenheiros. And then a few years later, in 2021, I've seen my membership of that institution upgraded to a senior member. Then in 2021 as well, I've joined WSP. I needed a bit of a change. I felt I needed a bit of a change, so I changed companies and I changed work. I started working for WSP as a senior structural engineer. And then not very long ago, this year at the end of summer, I got the result of my application for the membership of the Institution of Civil Engineers, of which I'm now a chartered member. So these are just some of the projects that I've worked on in the past. I can't show you all of them because some of them are still confidential and some of them are still being constructed, so I cannot share pictures for contractual reasons, but these are the ones that I can. So my first project was a project in Kazakhstan, in Astana. It was a shopping mall with an office tower with quite interesting design features. First of all, the office tower with hanging composite floors from the top of the concrete course, and also you can see in the image on the top left there's a garden on top of the shopping mall. So actually the loads that we have to consider to design the shopping mall were quite substantial. And there were some interesting features like composite, not composite, precast and post-tension concrete as well. But the biggest challenge on this project was the temperature design, because you might not be aware, but Astana is the second capital in the world with the largest temperature range. So we had to account for those temperatures. So that was quite an interesting project. And my second project was Tokyuman International Airport. So a very, very long structure in a seismic area. So that was quite a different challenge from the first one, but probably one of the projects I like the most to work on, and I've learned a lot on this one. And then the last one that I can show you from my period at Foster & Partners was the Tulip, of which I've made a presentation with Forum Civil a couple of years ago. It's not going to be built because the government vetoed its construction, so unfortunately it's not going to be built for sustainability reasons. I cannot pronunciate myself about that, but what I can say is that from a structural point of view, it was quite an interesting project to work on. But that's enough about me. Let's just move forward. So WSP is the company I'm working for at the moment. And WSP is one of the leading engineering consultancies around the world. We work in all sorts of fields related to engineering. We do airports, buildings, landscape architecture, transportation, infrastructure, all sorts of things that you can think about in a building environment. In terms of the UK business, we are divided into 5 different departments. We've got planning advisory, transport infrastructure, strategic advisory, property and buildings, and water energy. Last few years due to the transition to net zero. The most important one that I'd like to highlight here is property and buildings, because that's when I work, obviously. Although in my current project, since it is a railway project, it's kind of a joint venture between property and buildings and transport and infrastructure. So we work with some members from that department as well. Some of WSP's projects in the last few years include the Shard, which you might be aware of. So the Shard is the tallest building in London. Other projects include the Zayed National Museum, which is quite an interesting structure, and I've put it here purposefully because I actually worked on this project very briefly when I was still at Foster's. So that was actually my first direct contact with WSP from a professional stand of view. And then other projects include Fulham Stadium, Craven Cottage on the Thames Riverside. But the 2 core things that WSP is known about in the UK for doing is high-rise buildings and infrastructure. So you can see I've put there 2 images of the latest skyscrapers that WSP has designed in the London skyline. So 1 Blackfriars and 22 Bishopsgate. And incidentally, it's right next to the Shard, but it's a different project. Was the London Bridge Station redevelopment, which is one of London's largest underground stations in London. So that was the project that WSP developed a few years ago, and for a few years as well. In terms of staff worldwide, we've got about 50,000 people spread across the world. Our main areas are the United Kingdom and Europe and North America. Those are the places where we have the largest numbers of staff. And then if you look into Europe, the UK is where we have the largest offices, and with most people. We've got around 7,000 people in the UK, but we have a presence in other European countries as well. And the company has been expanding a lot in the past few years, either by hiring more people or by acquisitions or buying other companies that they then incorporate into the business. So that's it for an introduction about myself and my company. I'm going to start talking about now HS2. But before I start on HS2, I think I might as well explain to you what HS1 is. So HS stands for high speed. So HS1 was the first high-speed railway built in the United Kingdom. This was the connection between London and Paris via the English Channel, the Eurotunnel. And so that was HS1, and it was built about 30 years ago. HS2 is a second project, it's a different project, it's a different entity, but it's a railway project that I'm gonna talk about now. So HS2 is the biggest rail investment ever made in the north of England, and it's currently Europe's largest infrastructure project. It's a new high-speed line that will run between the north, the west, and the southeast of the country, connecting major UK cities like Manchester, Birmingham, and London, and its connection to the other railway networks in the UK will allow passengers to travel further afield to Scotland and Wales and other places in the country. The services from HS2 are currently expected to start running between 2029 and 2033, and that's when phase 1, which is the initial stage of the project, is meant to be concluded. So the project as a whole is divided into different stages. We've got phase 1, which is the connection between London, Birmingham, and the West Midlands. So the Midlands is an area of England between the north and the south, kind of the center of England. Then phase 2A is an extension of that line further afield to Crewe, which is sort of halfway between Birmingham and Manchester. And Manchester is where phase 2B of High Speed 2 will be concluded. Then there is HS2 East, which includes a connection to the east part of the Midlands with potential future services to Yorkshire, Leeds, and other cities around that area of the country. And then we've got the connection to the Northern Powerhouse Rail, which will allow connections of the HS2 services to the north of the country, to Scotland, and further afield. So in total, it's going to be around 250 miles of new high-speed line. So in terms of some key stats of the project, the operating speed of trains will be about 360 kilometers per hour. And just to give you an idea, so normal trains run at about 230 kilometers per hour. So it's almost double the speed. That's why it's high speed. In terms of trains per hour, so the phase 1 of the project, the project has been designed to have 10 trains per hour, so that's roughly 1 train every 6 minutes, and that number is going to be bumped up to 17 trains per hour, so almost double on phase 2. In terms of train lengths, we're talking about trains that are 400 meters long, and that they can be divided into 2 sets of trains with the front bits of the train separating if necessary to go to. So that it's actually a thing that happens a lot in the UK, that a train just does a part of a journey, and then when it reaches a certain station, the train divides into 2, and then the 2 halves of the train separate. So that's something that may happen on HS2, and that's been covered in the design. So in terms of traffic type, we're talking about passenger only, so there's not going to be any freight or any goods being transported on this train. It's only going to be a passenger trains. In terms of times, that's obviously the first benefit that people think straight away when you talk about high-speed rail. And that's obviously very important, but it's not the only benefit from HS2, and it might not even be the biggest one in my personal opinion. However, it's important to talk about it. So if you can see on the screen that we're basically halving the distances between Birmingham, London, and Birmingham and Manchester. It's the savings you can see on screen are very considerable, so that's going to be good to have those major UK cities connected with the length of time being shortened, because that's going to allow for people to, for example, commute between these several cities, and that's going to be very beneficial to the country as a whole. Because in the United Kingdom, what tends to happen is also something that happens a bit in Portugal, is all the services and all the economic activities centered in the capital, in London, the same way that it happens in Lisbon. And one of the ideas behind HS2 is that we're gonna level up and boost the economy elsewhere in the country. So by having good connections, good infrastructure and public transport connections between these cities in the UK, we're going to help the other cities to develop further and to have economic growth as well. So as I said, this is the immediate first benefit of HS2 is connecting these two cities, but in my view, there's a greater one. So it's not just about traveling fast, but it's also about releasing infrastructure for other services. So you can imagine that at the moment we have trains running from London to Birmingham, for example, and that those trains, they're occupying some space on the infrastructure, on the current infrastructure. If we are able to move those services away and put them in a different line, a high-speed line that's going to provide a better service for people wanting to travel between those two cities, then we're going to have spare capacity on the original network. And that will allow for a creation of further normal railway services in those areas. And so then cities and little towns between London and Birmingham will be able to have more railway services. So there's a boost from the in terms of public transport, and that's gonna eventually generate economic growth, and it's gonna benefit those cities and towns because they will have much better connections and they will have other benefits as well. So that, in my view, is actually one of the main advantages of HS2. Obviously, all this connectivity will generate growth, and as I said before in a few slides ago, it's going to help leveling up the country, so boosting the economy of these local cities and towns, that all of a sudden they will have more services and they'll be able to be more interconnected with other parts of the United Kingdom. And that, obviously, while we're building this massive infrastructure project, net zero transition, as we know, is on our mind. It is one of our main goals to achieve this project. So all our carbon Okay, yeah, I've noticed. So all the carbon emissions will be offset. We're planning to have net zero construction and operation from 2035. And one thing that is already happening in the construction sites across the United Kingdom is that we're planning to have sites running diesel free. So, for example, usually the cranes on site, they're operated by diesel, but for example, in Oldham Common, we're already not using cranes that are operated by diesel, they're electrical. So there's a big push from WSP and from HS2 to make this project as environmentally friendly as possible. And obviously, last but not least, this is going to be a boost for the British economy because it's a massive infrastructure project. And for that, it's going to obviously need a lot of people to work on it. There's going to be lots of needs for suppliers. So we're talking about the creation of 27,000 jobs just related with HS2, directly or indirectly, 950 apprenticeships, and we're looking at having about 2,500 suppliers benefiting from providing any sort of supply to HS2. You can see around the map that obviously the concentration of suppliers is much larger along the length of the project, where you have the HS2 line. But you can also see that there's suppliers all across the country that are benefiting from this project, even in places like Scotland. So obviously, that's also going to help level up the country by generating more economic activity around different areas of the country, not just in London. So I think that's pretty much it from HS2 from a macro point of view. So let's look now more into a micro point of view into HS2 Oldham Common. So Oldham Common is going to be one of the 2 London stations of HS2, and it's going to be part of HS2 until London Euston is completed. Old Common is going to be the terminus of the high-speed line. So London Euston is a bit more complicated project because it's an expansion of an existing station with some retrofit, and it's in the city center. So it's a bit more complicated project. So that's only going to be completed further afield. So in the initial stage, when HS2 services start running on the line, Old Common will be the final station in London. The location of the station is actually a very well-connected part of town, or will be a very well-connected part of London. So Old Common is in West London, and you can see on this map the amount of railway lines that we have passing nearby. So on the center of the screen, where you see those two boxes, that's where the station and mainline trains, which from London to the west of the country in Bristol and Wales. So that's also going to pass on this station, and as well as Crossrail, the now called Elizabeth line that opened only a few months ago in London. So that's also going to be connected directly in this station. However, there's also other services running nearby. So this area of town is going to be a major transport hub. We see London Underground, London Overground. There's lots of services here. So this addition of this new major hub here will actually create a boost for this area of town. This area of town is common. So a common is sort of a park. So this used to be an area of town that was a park. The difference between common and park in which is a park usually has fences around it. Common is just a field with grass and it's a bit less formal. In the past few years, this is a very old map, obviously, but that's where the station got its name and where this area gets its name from. But this area is known to have a lot of industrial activity and industrial warehouses, as you can see on screen now. So this was the site before the project started to be constructed. And that the industrial aspect of the project had some impact on the design from an architectural point of view. In terms of numbers, it's going to create directly 2,300 jobs. It's a lot of materials involved. We're talking about 73,000 tons of steel, 13,000 square meters of glass. But the most important numbers are probably the ones that are on the bottom of the screen on the left. So the project is going to have 14 platforms. 6 of them will be underground and will be HS services below the surface. And then the remaining ones will be Great Western Mainline services and Crossrail services. And perhaps even the most important number here is 250,000 passengers a day. So that's a massive number. Okay, it's like 2.5% of population of Portugal every day being on the train station, and that's just massive. And another number as well is that we have about 70 trains per hour. It's more than one train a minute leaving the station at all times. Not at all times, but at peak times. And that just shows you how much transport connectivity will be generated by this project. So in terms of the design bits of the project, I think we can divide the project into 4 parts. So we have the HS2 station in the center. We've got the GWML. So GWML stands for Great Western Main Line. So that's the station of the normal trains, so the trains that are not high speed, that are on the surface level. We've got the urban realm, which is highlighted in green, which is the area right next to the actual building of the station that's on the surface, where there's going to be parks and areas that people can hang out and that people can use while they're waiting for the train, or they're commuting to the station, and it's generally going to be a nice area to be on. And below all of that, we've got what we call the box, which basically accounts for the majority of the project. The box is the underground structure that allows for the tunnels where the HS2 services are going to come from. So the box makes the connection between those tunnels and the actual station itself. And that's the largest part of this project. So if we cut a cross section through the station, you can see that on the left we've got the HS2 box with the trains running underneath in what we call the B2 level, with the roof of the station above. And then on the other side of the image, you can see the GWML that is also covered by the same steel roof. And in the middle, we have something called the shared accommodation building, which the name I think gives it a bit wide, but it's a building that's shared with you and the station. In terms of the box itself, in the office, we usually call it the Burj Khalifa on the side because it's as long as the Burj Khalifa is tall. It's a massive part of the project. It's about 840 meters long, 50 meters deep. 50 meters. No, 65 meters wide and 16 meters deep. About 40,000 tons of reinforcement. Massive loads of concrete, 300,000 square meters of concrete, and more than 800,000 meters of excavation. So the box is monumental. It's just huge. And once I show you pictures of site, you will understand a bit the scale of it. So I think that was a brief, but now I'm going to look more into it from some side. So I'm going to start by the roof. I'm going to start from top to bottom. So the roof is a steel structure that frames all above the HS2 station and the Great Western Main Line station. It weighs about 2,750 tons of steel, and this is all weathering steel. I'm going to touch base on what weathering steel is in a few slides from now. So this is how the roof looks like from above. So in terms of structural systems, so the main idea is that the secondary beams are arch beams. So we've got fabricated steel boxes with hangers and the tie cable. So it's a tied arch, the secondary beams, and these are then supported by also fabricated box sections that are the primary beams. If we look at it in more detail, this is how the architects envisaged it to look like. So quite pleasant to the eye. You can see the secondary beams framing on the being connected to the primary beams, with the tie cables being attached to the bottom of the secondary beams, and then how this connects into the columns. And then I've put that image of that bridge over there just to remind myself to talk about weathering steel. So all the roof is gonna be built with weathering steel. So weathering steel is a sort of steel that it has that aspect, as you can see that bridge over there. It looks like it's rusty. It's a bit orangey and brown, but that's actually on purpose. So weathering steel is a special kind of steel that it kind of rusts, and the way it weathers itself, that actual layer of what we think that is rust actually is protecting the structure from corrosion. And for a big project like this, that it has a design life of 120 years, it's important to future-proof it and to minimize impacts of elements like corrosion and other similar things. So obviously, this is going to be the roof is going to cover a large area, and there's going to be humidity, and having good corrosion protection is very important, and that's why we went with weathering steel, because in the end it's going to be much cheaper for the client as well to provide, because this is a type of steel that actually protects itself. So in terms of maintenance, we're decreasing the costs over the length of 120 years by a lot. So those are major savings, and it's also structurally sound, and it's going to be beneficial to use this material. In terms of structural point of view, so I've spoken about the secondary beams, which are tied arch systems. So these run east to west, and these are supported on the primary beams, which are also fabricated box sections, which run normally from north to south. In terms of lateral point of view, we have, so the United Kingdom is not a seismic area, although one of the HS2 requirements for this and for the other HS2 and for the rest of the HS2 line is to design for earthquake. So even though the accelerations are very, very small, especially compared to a seismic area like Portugal, we still have to design for these loads. So in terms of our lateral system, it's much different from what you'd see in a seismic project, and most of my previous projects were seismic, so I was a bit shocked by the what we can do in countries that are not seismic. But in any case, we've got a mix of fixed columns at the front. We've got diagonal bracing at the back, at the back of the shared accommodation building, and we've got some stability cables around the west line. And as well, we've got a wind truss running all around the perimeter of the roof, so that it helps distribute those loads to the vertical elements. So this is how our SAP model looked like. So we've used SAP and GSA to design the station, so to design the members and the connections, and to estimate the movement due to wind and other forces of the station. So this is how it looks like. It's a very complex model. Takes a few minutes to run, and has lots of load cases, and it was quite an adventure to go through this model. But yeah, that's how it looks like. And this is how the project is going to look like once it's built. So you can see this is the main concourse area. You can see the cables and the hangers on the roof. Another viewpoint of the concourse area. And this shows a bit of integration that I'm going to touch on in the next couple of slides as well. You can see the roof lights there with the natural light coming from the outside. And this is how it's going to look from the outside. So the roof on its own is not just a feat from engineering, from a structural point of view, but it's also it was also an integration. It was also a job of integration between structure and other disciplines. So we've got roof lights that will allow the station to have natural light. We have integration with natural ventilation, so that's also going to benefit the station. And we have also solar panels and photovoltaic panels. So all this integration of these kind of features into the roof help the station be a bit more sustainability friendly. And they're gonna decrease the carbon emissions of the station. If it has panels and solar panels, that's reducing its carbon footprint and reducing its energy necessities. Another interesting feature that we've incorporated into the roof is on the bottom right picture. So you can see in sort of blue purple color, those are the gutters that run alongside the primary beams. So all the rainwater that's going to fall onto the roof is going to be collected, and it's going to be stored somewhere else in the station, so that water can be then reused for example, watering the trees and the parks areas of the urban realm. So there was a big push on the roof so that it could be as sustainably friendly as possible, and all the design has been optimized as much as possible to reduce as well the amount of steelwork that is used. And obviously having a system that relies on tied arches helps a lot, because it's quite an efficient system from a structural point of view. And this is how it looks from the inside, from the outside, from above. And if I remove the lid, this is how it looks like. You can see the HS2 station concourse at the center of the image, and then the concourse of the Great Western Mainline station. You can see the escalators going down to the underground and to the GWML platforms. And then if you keep going down, I think this picture helps me make the transition, a smoother transition between the roof and the box. So below the roof, we've got the box structure, which is a concrete structure, and you can see the elements there, the massive concrete elements, the props, and the and the columns as well in concrete, integrated with the escalators. And this is how it looks like if we do a cross section. You can see the several roof arches going from east to west, and you can see the trains that will run underneath the station and at the lower level of the box. This is how the in the box. So at the intermediate level, we've got our props that stop the wall from tilting in. They help with the stability of the box, obviously. We've got that, and we've got, it's not very visible this image, but you can see where the train is. That's where the so-called platform level. So looking at this image, one thing that is important to highlight is how the props will be working in compression, because they're helping the diaphragm wall resist the soil lateral loads. So that's why these members are look so big, is because they need to take massive loads of lateral loads due to the soil lateral pressures. If we look at it in section, this is how it looks like. So starting from the left, we've got the diaphragm walls that run all the way to the bottom, below even the base slab. We've got the base slab, the wailing beams, which I'm going to touch base on a bit later, the props, both on the level and the ground floor level. We also have some structures on the urban realm. So we've got some lightweight structures on the urban realm, steel, sometimes a bit of concrete as well, but we've got those supported on the ground floor slabs. And then at the center of this picture, you can see where the platform level is. So this is where people are going to take their HS2 trains. And we've got also the plunge columns and the piles underneath the columns. In terms of structural forces here involved, there's a lot of compression involved. So obviously we've got the lateral loads coming from the soil on either side of the diaphragm wall. And what helps keep the station all together is the props at ground floor and intermediate level that are working heavily on compression. And obviously the base slab as well, which is a member that is working both in compression and flexure, because there's a lot of pressure due to uplift, due to the water, the underground water, and also heave. And then obviously you also have a lot of compression due to in the columns and the piles, because these are very big spans. So the axial forces in those columns is quite significant. So there's a lot of compression involved in the design of this of the box. If you look at it from a level perspective, looking at the intermediate level, it's a bit well, it's the same principle essentially, but the way we distribute that force throughout the props is by having wailing beams on the intermediate level, and these at the ground floor level they'll call the capping beams. So these beams they work horizontally, sideways, and they help distribute the soil loads from the diaphragm wall to the different props, and so that they help us. So otherwise, if we didn't have any wailing beams, we would have probably punching shear problems in the connection between the props and the diaphragm wall. So by having the wailing beams, we help. First of all, we make it more stiff, so the movement is going to be less, and we help distribute the forces better, and that will help optimize the design as well. And this is how it's going to look like. So if you are standing in a few years' time in the B2 level at the platform, this is how you're able to see your train arriving. And you can see how the concrete is integrated with all the other elements of the station. This is going to be exposed concrete. So the architect put a lot of emphasis on exposing the structure in the station, and that's quite good from coming from a structural engineer point of view. I like to work with architects that they like to show how the structure works and to showcase these elements. Like if these elements were hidden, people would not understand how big these elements are, how much input into the design of this building. So it's always pleasant to see exposed structure. And then coming back to the surface level, just to talk a few minutes about the Great Western Mainline Station. So this, as I said before, the roof covers the Great Western Mainline Station as well. It's the same kind of structure. There's no movement trunks on the roof, and this is supported on a concrete structure at level 1. So this structure is ground bearing, is bearing on piles. So there's no basement on this part of the station. It's all at ground level, and the concrete piles support what we call the overbridge, and then the platforms will also be supported on piles, but those will be at ground floor level as well. And this is how it will look like if you're standing on a platform at the Great Western Mainline part of the station. So from here you'll take GWML trains, but also the Crossrail trains, that will be able to take you to central London, or East London, or Heathrow Airport itself as well. And the last bit of the design that I want to talk about is the urban realm, which is the area right next to the main station building. This you can see on this image the area that we have with parks and trees, and you can even see a ping pong table on the bottom corner of the image. So this is going to be a pleasant area to be, whether if you live nearby and you're just passing by, or if you're waiting for a certain train to depart sometime in the future, you can just wait outside, for example. If the weather allows, which in the UK is not that common, but you know. So the urban realm in terms of structure is divided into several buildings. We've got the east and west portals highlighted in orange in this image. We've got closer to the center, we've got the east and west cores, and in blue I've highlighted only two, but there's a few more ventilation shafts that are also part of the urban realm. So these are very simple structures. They're typically steelwork and some bits of concrete as well, but they're very simple structures from a structural design point of view. So there's not much story here on the structural design of them. But the reason why I wanted to highlight these in this presentation is because although the structural design of these was not very complicated, you can see the structural models there, they seem quite simple. The key challenge of these buildings was the integration with other disciplines. And that's something that when I was a student and I was studying structural engineering, you really have that. Obviously, I'm not criticizing that in any way. I think we need to know, as engineers, we need to know all about the forces and the stresses and the bending moments, and we need to be good about it. And once we've mastered that, that's when we need to open our horizons and understand that our structure does not work on its own. We need to take into account other disciplines as well, and that needs to be incorporated into the design. So although in our education we're not for students to be aware that in the future, once they are doing structural design, they will face a lot of challenges, not just from a structural point of view, but as well from an integration point of view of other disciplines. And then a couple of other points that I wanted to highlight on the urban realm are the inclusive design. So this is intended to be an inclusive design where, for example, one of the examples of inclusive design is the addition of ramps so that people that are on a wheelchair or a baby buggy can circulate around the station very easily. So that's very good for everyone. Everyone benefits from an inclusive design, not just people. And that's why I have that image on the bottom corner. That's an insect hotel. I had never heard about insect hotels before working on this project, but that's a feature that's going to be included in the roof of the east and west cores that will help species, namely insects, to keep their habitats in this area so that they are not just kicked out of this area and they lose their habitat. No, so there's a big focus on being environmentally friendly as well and proportionate types of features in the project that help the species and help the project be more green. And overall, this is going to boost up our BREEAM score. So BREEAM, for you probably are not aware of it, but BREEAM is a UK based criteria that evaluates buildings performance due to sustainability factors. And so all these things of doing an inclusive design and being sustainability, that will boost our BREEAM score. And currently we're ranking around excellent rate in the BREEAM score, but we still aim to achieve outstanding in the near future as the design progresses. So just a final slide on the urban realm. So the right-hand side picture shows you a cross-section, a 3D cross-section actually, of one of our models that integrates all the disciplines. And this comes to back the point that I was making earlier, that it's not just about structures, it's also about integrating structures with other disciplines. And you can see all the amount you see on the right hand side, we're doing the structural design of our concrete beams and walls and whatnot. And although it looks complicated, and it is, I'm not going to lie, it is, it all can come down to simple principles, and that's why I have the picture on the left. So the picture on the left was a sketch that I've done by hand, and then I've annotated it on the computer. My hand, nobody would understand what I wrote there if I didn't do it on the computer. But that just comes to show that with just a very simple hand sketch can give an idea to show other people in other disciplines how you can integrate all their needs together. And or if you start by simple basis, then you can propagate those ideas across the project. And given that this project is a kilometer long, the ideas are simple and easy for them to understand. That's going to make everyone's job easier. It's going to benefit the project as well. So that's just a message that I wanted to convey, that of something that we're not, in our education, we're not exposed to that, but it's something that you will be exposed if you become a structural engineer in the future. So I think that concludes the design part, and I think that I've spoken too much already. So I'm gonna pass the voice to one of my colleagues from HS2. So.
At Old Oak Common in West London, construction has started on what will be a station in the UK. The construction of the station will be a feat out in 3 main phases. In the first phase, the station build, this is where 6 high-speed platforms will be located, serving the Midlands and the North. To build it, a 1.8 kilometre underground concrete wall will be installed around the perimeter of the underground box. 160 steel bolts will be installed to form the box and support the structure. Concrete beams will be cast on top, tying all the elements together to form a large concrete structure. This will then allow the earth inside to be removed safely. The amount of earth taken out of the box will be enough to fill nearly 300 Olympic-sized swimming pools. In the second phase, as the excavation of the underground box is taking place, work on the 8 overground platforms will begin. Over 1,600 concrete piles will be installed into the ground on which the station's superstructure and overground platforms will sit. These platforms will then allow the Elizabeth Line and Great Western Main Line services to stop at the station. As the high-speed platforms and the overground platforms are being completed, the high-speed 2 station and the surrounding urban area is built, the third and final stage. The main element of the station will be its immense roof, covering the 3 footbridges designed to minimise the use of materials and allow as much life reduces the carbon impact of the station. To further boost its environmental credentials, the roof will be covered with solar panels, generating a supply of renewable energy for the station. This curved design of the roof brings together the 3 different ranks of one unified building, creating a common experience for the passengers, turning it into one super hub station. With over 250,000 passengers using the station every day, Old Oak Common will be the best connected and largest new build station in the UK, making it one of the country's most vital transport hubs and a catalyst for economic regeneration for the area and the rest of the UK.
So I think that was a bit of an introduction on the construction bit. So as my colleague, not really colleague from HS2, HS2 is the client of the project, but what the woman in the movie was talking about, she spoke about top-down construction. And I thought I'd have a couple of slides just to highlight these, because I don't know, maybe some of you guys had already have TCE, Tecnologias de Construção de Edifícios, with Professor Brito. I think it's in the 4th year of the master's. I can't remember exactly, but you're probably going to learn this there if you haven't. So top-down construction is a very efficient method of constructing underground buildings. So as to showcase this example from our station, so we started by installing the diaphragm walls, as you've seen on the video. Then we've installed the plunge columns. So these are steel columns that are pressed into the ground. And then we start by building the ground floor structure. So as we build the ground floor structure, we start to be able to excavate and to create the space required to build the foundation. And we do that by following a hit and miss plan, as you can see on the top right corner of the screen. So a hit miss plan basically means that between every 2 props, we're going to have a slab, but we're not going to cast all the slabs straight away. So we leave empty voids so that we can have a digger to go there and remove the earth from the ground, and then that's going to be done sequentially, and then we can start building the floors below. And if we keep doing that, we can keep digging and building structure, making that everything is stable and that the structure is in equilibrium. And we can also start to think about building the upper floors at the same time that we are finishing the excavation on the bottom part of the station. So that it's quite an effective way of building these sorts of projects, and it's one of its major benefits. It's time saving, because we can build the underground part of the structure as well as the superstructure at the same time. And for a project of this magnitude, is obviously time saving is money saving a lot. So it was I think it was a very good choice from the construction side. Yeah. Then I'm just going to show you a couple of videos of the construction site so that you have an idea. So you can see here on the right-hand side, this is the site office. This is where I work when I go to the site office. But just to give you an idea of the scale of the site. So these are drone images taking actually during the summer. So this is how large the site looks like. What's going on at the same time, different areas. So it's a really hectic site. And then the next one, the east part of the box. So for you guys to have a feel for how long the project is, there is a bridge coming in the center top of the screen. You can see some trusses. I think you can see, if you can see my cursor on screen, there's a bridge there. So that's where the overground line passes. So the train that I take to go to site to work on site. And this is the closest I've been to the east box, so the east part of the project. So from the site office I can't see it, but when I'm commuting to the site, I can see it better from the train than actually from being on site. So that shows you how large the project, the site actually is. Yeah, and then a few pictures from sites. So this was a few weeks ago from the cranes and the reinforcement cage. See the company installing all the bars and the amount of rebars that we have in those massive structural elements. And to give you a sense of scale, this is how big those cages are. Like the tops are 2.5 meters by 3 meters, quite massive structural elements, and you see that by comparing it to the size of the workers on screen. Some pictures that I've taken from my lab. Some things that I've thought they were interesting. So you can see a few weeks ago they were casting the ground on the west block, and then a week later I to site and in the same location. The slab was already cast, and there was already a digger starting the structure for the following construction that I don't know before. And then another interesting set of pictures that I've seen was, I don't know if you can see on screen that there's this GL09 on the top and GL10. So that's the grid lines. So the same way the project in AutoCAD or Revit or whatever drawing software, we also have those on site, which is quite interesting, so that you always know in which part of the project you are. And I was able to follow in consecutive site visits the construction of prop on grid line 9. So one of the times that I went there, they were assembling the reinforcements for prop number 9. And then the next time that I went on site, they were already, that needs to be attached properly. And on the same day, the concrete pump came around and started pouring the concrete on that prop, and by the end of the day the concrete was cast and it was drying. And I think that's yeah, I think that's it. Before we go on to questions, there's another video that I want to share with you just to conclude the presentation, to give you just a kind of a takeaway from this presentation. So just.
HS2's Old Oak Common Station will be one of the best connected and largest new build railway stations in the UK, making it one of the country's most vital transport hubs and a catalyst for economic regeneration. Located in West London, 3 major rail lines meet here: HS2, the Elizabeth Line or Crossrail, and the Great Western Main Line. And we've designed the station to make it as easy as possible for passengers to change trains and make their connections to all points, north, south, east and west. As you enter from the vast public space in front of the station, you'll be struck by the open concourse and the sweeping roof. The roof design creates a sense of space and calm, and to allow passengers to find their way around the station easily, reducing stress on their journey. For passengers taking high-speed trains, that means heading 15 metres below ground to the 6 high-speed platforms. Here, passengers can take trains to the Midlands or up here and change onto their onward journeys to London, Heathrow, or connections to Wales and the southwest. Whether you're switching lines or leaving the station, you'll head back up the escalators to the ground level concourse. We've designed to maximise passenger. From here, you'll make your way to the 8 platforms serving the Elizabeth Line, Great Western Services and Heathrow Express. At these platforms, you'll catch train to central London, Canary Wharf and Heathrow, and longer distance services to Bristol, Exeter and Plymouth, as well as Cardiff and Swansea. This unrivaled connectivity at Old Oak Common Station will play a huge part in rebalancing the UK economy, bringing Britain closer together and connecting our major cities.
So that was it. So if anybody has any questions, now is the time. If you want to just type them in the chat.
Booking.com, we know how to travel.
Okay. If you wanna type it in the chat or just ask me. I don't know if there's anyone that's not a Portuguese speaker, so if you guys want to do the questions in Portuguese, I'm happy to do so as well.
I think there are 2 students from abroad. My question is there any way, or is it possible to extend the line through all Europe? Like a high-speed that is specific to England?
So no, it is the same. I can't remember the English term for it now, but Bitola is the same as a high-speed one. So actually, that's an interesting question, because when the idea of HS2 first came about, the idea is that it would be a continuation of HS1. So you would leave the HS1 service in one station and then that train could continue or move to another train in the same station. But that proved to be a very expensive thing to do, because the terminus of HS1 is in the city center, and the tunnels with this magnitude, the ones that we need for HS2, that would be really expensive to do in the city center of London. So that's why the station was then, the terminus of the station was moved to London Euston, because there was an opportunity there to do it in a more economical way, but that's also why Euston is taking a bit more time to be completed. But there was an initial idea to have those interconnected, but that has been dropped due to cost issues. But any case, the terminus of HS1 is in and that's only, I don't know, 5 minutes walk from London distance. So it's not going to take you a lot of change between those two trains.
Yeah, can you hear me?
Yes.
Okay, so my question is, in terms of innovation, were there any new technology used in the either in the design or the construction itself?
Well, from what point of view? From the design point of view?
Point of view, the construction or the methods or the anything.
Yeah. So, for example, for the roof, we've used the grasshopper to come up with the actual with the structural model, and with using grasshopper links and ETABS and SAP. So that's a very trendy thing nowadays, to use grasshopper links to come up with difficult and complex geometry models. From the construction point of view, I can tell you that this is the most high-tech site in the UK at the moment, and we're going to have a lot of features that are high-tech. So that, for example, the concrete slabs and the props, they will have sensors inside, so that we will be able to monitor the stresses of the structure throughout the lifetime of the project. So we know that if for any reason something starts to go wrong, or for example, if the load estimates that we've taken, for example, for the water, or if some load for some reason unexpected also turns out to be much greater than what we've accounted for, that's going to be captured by sensors. That's going to be stored in the computer, and that will raise alarms. So we will know that something needs to be done to avert any possible structural failure. So that's one of the ones that I can think about. But generally, I can tell you, yes, I can't give you more concrete examples of that because the construction hasn't started that long ago, and I haven't been involved so closely with construction as to know that. But I know that it's the highest tech site in the UK at the moment.
I would like to know what type of soil exists on that area of the station, and yeah, what it is.
It's London clay, so that's the classic. So the soil in London, you have very thick layer of clay all over London, and then below the clay you've got sand, but sand only comes about usually around 60-70 meters depth, so we don't reach those depths yet. So it's all in sand, but in clay. An interesting feature of the design was the water level high, and we have there's a canal running nearby, and we need to account for that canal, for the possibility of that canal bursting and there be floods around the station. So we have that into account in our design of the foundation elements as well.
Thank you.
Hello?
Guilherme, can you hear me?
Yes.
Hello? My microphone.
Qual é a tua pergunta?
If the station is prepared for to accept other types of trains other than fast.
Guilherme is asking if the train station allows types of trains to get there, or only high-speed trains.
Yeah, so that was, I think I've touched base on that before. That was, let me see, I have a slide with that actually. Let me just try to find it. So yeah, this slide. So you can see here. So the HS2, the high-speed services, they will be the ones underground. So we have 6 platforms of HS2 services on the left-hand side here, and then all the services above the surface on the ground level. So the Great Western Mainline services and the Crossrail services. These are normal These are normal trains. They're not high-speed. So these will be connected on the ground surface, and all of these will be part of the same station. So the roof structure covers the whole thing, and it's only one station. But so we have 14 platforms. Only 6 are high-speed trains. The remaining ones will be normal railways. Although there is as well, since there is for the future, it's not planned yet, but there is plans to do a connection to also the overground services that are the London Overground. So the underground is the obviously underground train. The overground is kind of surface. So there's plans for the futures for smaller stations to be built in the vicinity, and that they could be connected to all the common stations.
So in the construction, you took into account the future and the possibility of expansion, right? Of the necessity of building another types of transport infrastructures.
Well, yeah. Yes, there are some. We've taken that into account in the design. There are parts of the project that they're future-proofed. We have we call it the day 1 and day 2. So day 1 is now what we're building now, but those particularly parts of the station that could have future connections, we have a day 2 scenario for them where we have different loads, sometimes higher, sometimes not so much. But in our design, we take the biggest loads that we need to take. So yes, there is the station is future-proofed for expansion as well. I don't think so, because that would require a major infrastructure change in the project. I don't think that's on the cards. I know that's used a lot in Japan, for example, but I don't think that was considered for this project.
Well, if there's not any more questions, we can end up the lecture. Thank you so much, Engineer Pedro Carvalho Costa, for your.
Yeah, my pleasure, and thank you all for attending. And it's been a pleasure. So I'll see you next time.
So I would like you all to, if you can, to turn on your camera so we can take a picture, a screenshot, so we can publish on our social media. Those who.
If the engineer can take a presentation, it will be better to take the picture.
Oh yeah, sure.
Sorry.
I'll stop saying.
Thank you. Wait.
Ao contrário aqui que eu disse.
Is it?
Another one, please. Okay, I think it is.
Okay. Thank you so much. Bye.
Então eu era quem? Eras eu. Lucas não.
Bye, thank you.
Thank you very much.